Hello everyone, welcome to my chemistry channel B.L.DASH short and sweet in chemistry. Now I am going to explain numerical application in chemical kinetics, that is introduction part, where I want to show different graphs representing different order of reaction and also the summary of the different equation. This is part 6. Here graphs representing different order of reaction. You can see the concentration is y-axis, and here this one time is the x-axis. So here you can see this is the time in x-axis and this is the concentration, that is y-axis. And you can see the concentration in initial time, that the time is 0, then it is the full concentration. And now when time is proceeding, that increasing, and here the concentration of the reactant decreasing in this manner. And here the products also, when time is 0, it has no product is 0. When time increases, the product also increases. That means this is the graph where concentration decreasing, product increasing, and concentration of reactant decreasing. It shows the graph where concentration versus time. Then come to graphs for the zero order reaction. Actually, there are three types mainly: zero, first order, second order, also third order is there. Now you will see what are the different graphs already taught in previous videos, but I want to explain as summary graphs for zero order reaction, and this is the rate and versus concentration. Rate in what axis? Y-axis, and here concentration is x-axis. You find here it is a parallel line and to the concentration. Now then come to concentration of the reaction. Here in reaction, what are the concentration with the time? When time increases, and here what happens, see that one intercept is there, that is intercept are 0, and here k equal to minus slope and slope equal to minus k. This is also in the form of y equal to mx plus c. Now you can see here that is T half. In T half, half-life period versus initial concentration, you find the graph that is coming from the origin as a straight line, and here is slope equal to k. Then come to first order reaction where rate versus concentration. This is y-axis and this is x-axis, and here the straight line comes from the origin, and here log r. What is log r and ln r? Log r, there is no 2.303. So when you draw the graph, that is the graph is plotted between log r as y-axis, here log r as y-axis, in time in x-axis, you find the graph. Then the formula, what is the formula? Log r equal to minus kt by 2.303 plus log r0. Now see how it is the form of y and equal to mx plus c. This is y and this is m, and x is here mx, where m is the k by 2.303 minus k by 2.303, and here x is the time and c, that is intercept, that is log r0. So this is the graph where in the form of y equal to mx plus c, and this is known as c. Similarly, when we change to ln r, then what is the graph? The graph is like this, where ln r is the y-axis and x is the x-axis, that is t, and the k is the minus slope. This is the axis. This is the graph in the presence in the form of ln r versus time. And now if you go to log r0 by r, then what is the formula? See, log r0 by r, that is y, and t is the x. Here m x. What is m? K divided by 2.303. That means here slope is k by 2.303, and the this is y and this is x, and y is the log r0 by r, that is the molar concentration sign you should put, and here slope equal to k by 2.303, and this is the formula where y equal mx plus c, where c is the 0, no intercept. Then come to t half. T half also in the y-axis, and r0 is the x-axis. A graph is plotted. A graph is plotted to the x-axis, so here no slope is there, and this is the all the different forms of graphs in first order equation. Graphs for second order equation, here you can find 1 by r, this is y-axis, this is x-axis, and intercept is 1 by r0. That means what is the equation? This is the y. Here intercept is this one, 1 by r0, and k is the m, t is the x-axis. So y mx plus c. This is the graph, very important. Then t half at y-axis, and this is 1 by r0, initial concentration, that is as x-axis. And here it is a single graph that comes from origin, and here slope is k. And similarly here rate, since it is second order, rate when that is equal to k, rate equal to k, then r to the power square, square means here second order, so this is the graph as a straight line. Similarly for third order, rate versus r to the power 3, then it is also a straight line. So is it clear? I think for 0 order, first order and second order graphs. Then conclusion. Then what is the conclusion? Concentration of reactant measure as a indifferent time interval by any suitable method, that is graph or integrated equation method. So instantaneous rate are plotted against A or A2 or A3. Any graph you can, rate graph you can plot it, that is versus A to the power 1, A to the power 2, so or A to the power 3. And straight line is obtained from graph, that is rate and A1, that is first order, rate equal to k, A to the power 2, that is second order. Similarly rate equal to k, that is here you can write r also, A also, so you can write here r, actually you can write here r. So here you will see instead of A you write r. So r mean reactant. You can first it is in the, it was there in a form of A, but nowadays it is in the form of r. So this is the first, second, third order, where rate equal to k, r to the power 1. For second order, rate equal to k, r to the power 2, and that is rate equal to k, r to the power 3. These are known as first order, second order and third order. See, so here easily form the graph where rate one side and this one versus rate versus reactant. So you can find here three different graphs where all are having straight line as a graph. So it is easy to know where from the graph you can find what are the order of the reaction. Significance of integrated rate equation. It is very easy to find the value of rate constant from the integrated rate equation. Very important also first order reaction, where first order reaction having the equation K1 equal to 2.303 T log R0 by R having molar concentration sign. These are all the things explained in previous videos. So what is K? K, you can write also what is K1? K1 means first order. So here you can see instead of R0 you can put A. Actually the concentration of R in initial concentration you can explain as A, and R equal to A minus X. So what happened? If the value of K1 is constant, then all we are getting constant having 3, 4 values, then it is first order. Calculation of rate constant K1 for the first order, how you will calculate it? From the integrated value or from the different graph. So if the reaction is first order, by putting the value R0, concentration reactant to different value, the value of K can be calculated. That means you put the different values and different graphs and lastly calculate K. If the value is remain constant, then it is called that is rate constant, that is for the first order reaction. You can see here the equation, that is K1 equal to 2.303 and log R0 by R. What is R0? Initial concentration. And what is R? That is concentration at particular time. So here K1 is the first order constant. So after calculation, see, observe K1T by 2.303 equal to log R0 by R. Lastly, you will get log R equal to, this is log R, equal to minus K1 by 2.303. This value is known as M. This value is known as M, and log R, this value is known as Y. That means Y equal to log R, and that is slope M, that is called slope. Y equal to mx plus c, this is slope, and t is in x-axis, and R0, log R0 is the intercept. Here you will get a straight line just like mathematics, y equal to mx plus c. And here you will find that y equal to mx plus c, where log R is y minus K1 by 2.303 equal to slope, and x-axis is t, y-axis is log R. Here you will get a straight line if you take it different times. So from here you can calculate K1. Then summary of the type of reaction, reaction, and what are the type of reaction you can observe till now. What you are observing? Zero order, first order, second order. Zero order reaction where rate equal to K. That means when rate equal to K, this is zero order reaction. It never depends the concentration of the reactant. So R equal to minus KT plus R0. What is the meaning? This is Y, and this is MX, and this is C. So here the graph you are drawing, that is you are plotting the graph R versus time. And here the slope is minus K because M value is minus, so slope is minus K and intercept is R0. It is clear, already explained so many times. This is, I hope in summary you should recollect all the knowledge of zero order reaction, and here the summary. First order reaction, rate equal to KR. R means concentration of R at a particular time. So log R equal to minus KT by 2.303 log R0. That means log R is the value of Y, and it is the value of M and X, where X is the time, log R0. So what is the graph you will draw here? Log R versus time. time, that is you will draw a plot a graph, you will get a graph, and where the slope is minus k divided by 2.303, and what is the concept, that is intercept, that is the c, that is log r0. That is where you put molar concentration sign. Second order, rate equal to k r to the power 2. This indicates that it is second order. If it is third order, then what will the equation? Rate equal to k r to the power 3. Then what is the here equation, integrated equation? 1 by r equal to kt plus 1 by r0. Then what is the y? What is the y value? This is the y, and this is the mx, and this is the c. Then 1 by r versus time, you will get k, and here k is the slope, and intercept is 1 by r0. What is r0? Molar sign. This is initial concentration of the reactant. So I hope it is clear. The zero order, first order, second order, and these are the equation, integrated equation, linear plot, slope and intercept. This is the conclusion of the first, second zero order reactions. Then you will see type of reaction. If you see zero order, what is the rate equation? That is very important. You should know, you should remember rate equation. So this is the rate equation. Zero order, rate equal to k r to the power 0. That means when anything power to 0, that is equal to 1. So what is the value here? Then rate equal to k. And similarly, what is T half? R0 by 2k. Already this is calculated, and faster reaction rate equal to k r to the power 1. So 0.693 by k. And second order, rate equal to k r to the power 2. So this is the second order. What is the T half here? 1 by k and r0. That is molar concentration. That means how can you say 1 by k r0? So this is the rate equation and T half value for the zero order, first order and second order. I hope it is clear to you. All the things are repeated, but it is written in short form in part 6, so that you can remember, you can recollect all the values, how the graph is drawn and what are the calculation. Very helpful to the numerical application, numerical problems. After that we will see. Again, thanks for watching my video. Thanks again. I am B.L.DASH, ex-PGT Chemistry, Kendra Vidyalaya Sangathan. Thanks you again.